We've looked at vector operations from a graphical approach. In this video, we will approach vector operations from a symbolic approach. Another way of adding or subtracting vectors is by considering what we call the components of the vector. A vector is comprised of two components. We have the horizontal component in the x direction, and we have the vertical component in the y direction. Written as a position vector, we've seen the notation where the components are now clear. In this position vector, we know it's a position vector because of the sideway v's that are on there. But what we're saying now is that when we take the difference in the x values and the difference in the y values, that those are actually called components. All right? So we're not doing a whole lot different. We're just giving some vocabulary. Let's take a look at an example. In this example, we are given in a graph vector u and vector v, and we're being asked to write those in component form. All right, so we'll begin with vector u, and we're going to write that as a position vector. Now, what that position vector entails is determining from the initial point of vector u to the terminal point of vector u, what is the horizontal and the vertical components of that? What's the horizontal and vertical movements to get from one spot to the other? Now, here's what I see. I see that starting at the initial point, I had to move to the right 1, 2, 3, 4, and 5 units, and then I have to move up 2 units. So I'm going to call this 5, 2. 5 and 2 are the components. For vector v, same idea. The position vector for this one is going to be, looks like a horizontal movement from the initial point to the terminal is going to be 1, 2, and 3, and then down 1. So I'm going to call that 3, -1. Now, calculate the sum of these vectors by adding the horizontal and vertical components of vector u and v. That's what it's asking us to do on part B. Okay, we haven't done this before. Here's what I'm going to say. I'm going to say that vector u plus vector v is equal to simply taking the horizontal components, which are 5 and 3, and adding them, and then taking the vertical components, 2 and -1, and adding those. When I do that, I get the position vector of 8, 1. All right, now the way that we added vectors previously, when we were only interested or only able to graph, is we would take vector u, which we see in the graph, we would take the terminal point on vector u, and we would connect it to the initial point of vector v. We would then draw off that triangle, close that triangle, you might say, and that new vector would become our sum. Now we're saying that all we really have to do is just add the first components and the second components, and that just gives us the new vector. Now, we want to verify that using a graph. So let's take a look at this graph. If what we say is correct, then I should be able to start at the origin and then move to the right 8 units and move up 1 unit. And that creates the vector u plus v. Now, is that vector u plus v the same vector that we would have seen in the graph above? Well, if we just move it, bam, there it is. Okay, so which is easier? Is it easier to connect using a graph, or is it easier to connect by simply adding pieces? That's up to you to decide, and there may be times when one is better than the other, but I will say as these numbers get larger and uglier, it may be to our advantage to not have to plot the points and simply use the sum of the two different components.